So today we're talking about special rules of logarithms. Some of these we've already discussed, and you guys have actually you've actually figured them out kind of on your own. For example, remember this one right here? We realize that if you have a log and it has a base b, and this number is a b, then the answer is just the exponent, right? In this case, it's the y. The same thing over here works. This is saying b to the log b power of x, and the answer is just x. Basically, when things match, they cancel out, and it's just your answer. Also, yesterday when we were working on our log facts, we found out that anytime you have 1 in this spot, the answer is 0. If we ever have 0 in this spot, what's the answer? No solution. Okay? So you might even want to write that one down too. But if you had log base b of 0, that answer will always be no solution. Okay, so moving on. With those rules, hopefully you can figure out the answers to most of these questions. On number 1, what do you think the answer is?
27.
Good. These match, so they cancel out. Your answer is 27. Example 2. The answer is 5. These match. The answer is 5. Okay. Now on number 3, I don't see anything matching, but this log right here doesn't have a base, which is 10. Therefore, is there matching? Yeah, because this is really 10 to the log base 10 of 2. Therefore, those cancel out, and the answer is 2. So be careful. Remember that anything that doesn't state the base of the log is automatically base 10. Okay, so what do you think we should do on example 4? Well, this already is log base 6. Basically, whenever I see that this is base 6, I look at this number and I'm like, can I write that as a base 6? It's not 6 root 2, it's 6 to the... So this is really log base 6 of 6 to the second power. Therefore, what is my answer going to be? 2. Very good. Okay. This one sometimes confuses people because of the x and the exponent, but that just means that your answer is going to have x in it. Okay? So because I have log base 5, I want to see, can I write 125 as a 5? Good. So this is really log base 5 of 5 to the third power, but there's already an x there, so I just have to keep a x there. Therefore, what is my answer? 3x, exactly. Okay? And what is my answer going to be for 6?
0.
Very good. So whenever you see that, you just know that the answer is 0. Do we need to work through why that one is true?
No.
Okay. All right. So if no base is shown, you assume that it is base 10, which is your common logarithm. So we already know this, it's just showing you. So this was saying there's no base 10. This is when they put the base 10 in to show you, and then this is changing it to exponent form. Okay? So they're asking us to simplify this. What would be my answer for 7?
1.
Very good. This isn't saying the base, right? Yeah. But we automatically know it's log base 10, and then it's of 10. And what exponent is this 10 have right now if it doesn't say it? A 1. Therefore, this answer is 1, because those match. Okay. What about example 8? Very good. How did he figure out the answer is negative 3? Because we've done a problem like this before? Okay, 1,000 is actually 10 to what power? 10 to the third.
But it's on bottom, so you have to go on top.
which gives it a, so this is really log base 10 of 10 to the negative 3. Therefore, those match, and my answer is?
We are not about to use pi.
Yes, we are. Okay. There is a new number in math, well, new to us, but it's actually been around for lots of years. What we're going to be talking about is E. Okay? E is an irrational number just like pi. Okay, so you know how we have pi is approximately 3.14. E is another number just like pi, which is 2.718. Yeah. And pi goes on forever. Okay, that's just part of it that I have posted. Yes. Okay. So oftentimes we don't necessarily use the number, we just keep E in our answer. Okay, but if you look on your calculators, if you guys want to get your calculators out here real quick. Or if you don't. But look right here. We're going to be talking about this here in a minute. But see right here, this says ln. ln is called natural log. Natural log is dealing with E. Okay, if you look above natural log, do you see how it has e to the x power? Yeah. So just like how we have pi in our calculator, we also have e in our calculator. Okay, so when we're finding out an answer for e, I can go second, and then my natural log, which is saying e to some power. So it's saying e to some power. So if I wanted to find out, well, what is e to the third power? That is approximately my answer. Okay, I know, pretty fun stuff. Math is just awesome. Okay, so E though, how, you know, log is dealing with base 10. Are you guys with me? Log deals with base 10. Hello? Some of you are not paying attention. Thank you. Natural log is dealing with base E. Okay? If base E is used, it is called a natural logarithm. And instead of writing log, we use natural log when you're dealing with base E. Remember that E is just an irrational number. It's approximately this 2.718. Yes?
What's up with it being ln instead of nl, or natural log?
Great question. I don't know. That's just the way it is. Weird. It's already printed on the calculators, everything, so we can't change it. But yeah. Okay. So, all they want you to do right now on these is write each in exponential form. So all we're doing is changing this to exponent form. So how would I write this if I wanted to change it from log form to exponent form? Pi to the third power equals 31.01 is correct. Now, I just told you this, but what base does, how log has a base 10, natural log has a base E. So how will I rewrite this one in exponential form? That's funny, and we already did that on my calculator just now, didn't we? I didn't even realize it was in my notes. Kind of funny. All right, questions there? Okay. Nope, we're moving on. Yeah. Just till the end of this page right here. All right, so to graph a log equation, the first thing you want to do is, gentlemen. Yes, Courtney. It was blowing out cold air. First, write it in exponential form. Okay, so the first thing you want to do when you're graphing a log equation is to write it in exponential form. Most of the time when we're writing something in exponential form, we have the log part on one side and then it would be equals y on this side. Okay? So if it's not written the way that you like it, rewrite it. Okay? So how will I rewrite this equation in exponential form?
3 to the x power equals 1.
No.
3 to the y power equals x.
3 to the y power equals x is correct. Okay? So this is my exponential form that we're going to use this in order to fill out our chart so we can plot points and see what the graph of this looks like. Okay, so we make a list of tables. Notice that, and I did this for you here, but since y is in the exponent, those are the values you want to choose. And then you want to find the answer for x. It's more difficult to put values for x and figure out what the answer would be for y. Okay? So we choose whatever the values for whatever's in your exponent. Okay? So we're choosing these 2, 1, 0, negative 1, negative 2. So when I plug 2 in here for y, what is 3 to the second power? 9. What's 3 to the first? 3. 3 to the 0 is 1. 3 to the negative 1 is 1 over 3. And 3 to the negative 2 is, very good. And then now we're going to plot these points. So I think this one is not on the graph. So if we go, is it exactly 9?
It's the last one.
Okay. So 2, 9, we'd go, or sorry, 9 and then up 2. Okay? Always x and y. 3 and then up 1. 1 up 0. And then it's saying 1/3 negative 1. And then 1/9 negative 2. And so this graph looks like this. Does this graph remind you of something?
Oh, I can't touch the y-axis now.
Very good. It's very similar to the growth and decay problems in our exponential equations that we were doing last unit, but this time notice that it's not going to touch the y-axis. It'll get very close, but it will not touch the y. Notice the difference. In last unit, we had x's in our exponent. This time we have y's in our exponent. So if y is in your exponent, it can't touch the y-axis. If x is in your exponent, it's not going to touch the x-axis. Okay? All right. So example 12 asks us to make tables and graph y equals 2 to the x power and then y equals log base 2 of x. Okay, so y equals 2 to the x power, this is what we dealt with last unit, and this is kind of showing you how the graphs work. Okay, so if we graph this one first, if we put 2 in for x, and notice since x is my exponent, I'm choosing values for x. When x is my exponent, I'm choosing values for x. So when I plug 2 in here, 2 to the second power is 4. 2 to the first is 2 to the 0 is 1. 2 to the negative 1 is 1 over 2. And 2 to the negative 2 is... Okay, so which line is this not going to touch? The x-axis, because x is in my exponent. Okay, so when I go over 2 up 1, 2, 3, 4. Over 1 up 2. 0 up 1. Negative 1 1/2. Negative 2 1/4. And so this graph looks like this. And again, it should not touch my x-axis. How will I rewrite this one right here? What will this end up becoming?
2y equals x.
Good. 2 to the y equals x, which is why I chose values for y, because y is in my exponent. And what line will it not touch? The y-axis. Good. So when I plug 2 in here, 2 squared is 4. 2 to the first is 2 to the 0 is 1. 2 to the negative 1 is 1/2. And 2 to the negative 2 is 1/4. So when we graph this, we go over 4, 1, 2, 3, 4, up 2. Over 2, up 1. We have 1, 0. And then we have 1/2 negative 1, 1/4 negative 2. And so here is my graph. So basically, these are, does anybody know what this is in math terms? What these are?
No.
They're a reflection of each other. Okay? That's a geometry thing, kind of. All right. Any questions?
No, man.
All right.